Hello everyone, my name is Aidar, and in this video, exercise 5, climate forcing data part 1, I will talk about data extraction and preparation. First of all, you need to open RStudio and load our libraries. For this video, we will need libraries Tidyverse, Lubridate, TimeTK, SF and Terra, libraries for spatial processing. We would need library rChelsa for downloading the Chelsea data, and we would need Reverse Central Asia package for data processing. After that, we need to specify our variables, river name, basin name, gauge code, and we need to load our CSV discharge data to the variable U7461. Here in configuration, you only need to change the passes to the directories. For example, here we have the JS directory with the JS files, and here we need to change the directories to the observation, simulation, data, future simulation, data, and the directory with the RS Minerv model. For example, I have here a folder where I would have RS Minerv model files. I right click it, copy as path, and insert it here. And again, I have here the backslash instead of slash, and I press Ctrl F and write here slash, click all, and then it will change automatically everywhere where we have backslash to slash. The Chelsea data will be downloaded in the code below here, but if you already downloaded, you can comment out this section of the code like this and don't run it. Historic simulation and future simulation you can access through the Dropbox in the book, or you can download it by yourself, you can go to the book, to the chapter 7 or in the part 2, data sources, climate data, and here in the part where climate scenarios are discussed, you can find the link to Copernicus website. You can open it, and here you can download the climate projections. Here you can choose the scenarios that you need for your research. And here there are variables. There are air temperature, precipitation. Here are the models that you can choose. You can choose one model at a time. Here you can choose the time range. And here you can choose the months that you need for your work and days. And here you can download for the whole Earth or the sub-region. For example, here are approximate coordinates for Kyrgyzstan. And here we can choose the format, and then you need to submit to download this data. But before downloading, you need to log in to this website. After you have your historic GCM and future GCM simulation data, you can proceed to the load the Chelsea data. As I said before, if you already downloaded, you can just leave it commented out. But if you don't have this data, then we need to run it. Important notice that it takes a long time if we want to fetch the data from the entire 30 years all at once. Therefore, we fetch the data year by year. And all these files are in the 4326 projection. Important parts of this code is the extent where we have our basin. Remember in the previous videos we created the basin. Here is the watershed file. Here in the beginning we load the watershed to the R. Next, use this basin in order to get the Chelsea data only for Zerashan River Basin. Next, we define our start date and end date, and we Start date is defined here in the historic observation start. It is defined in the configurations here. Right now it is set to the 1981. Next we have a for loop that is downloading the data in Kelvin, and here we converting Kelvin to degrees Celsius. Here the precipitation files are prepared. If you run it, Chelsea data will be downloaded to the folder that you specified here in the historic observation directory. I specified it to the historic observation directory. Here is an important number, important variable, where we specify the number of years to download. For example, here I downloaded to the folder Chelsea 30 years of precipitation and temperature data. There are 60 files here, and I downloaded these files by using this code and using this 30 in the variable number of years. If you, for example, need only 1 year of data, for example, like this, you need to change only the number here, and the code will download you only 2 files, 1 year of precipitation and 1 year of temperature. I already downloaded the data here, that's why I will not run it, and I will just comment it out. But if it's your first time of using this code and you need this data from Chelsea, you can run it, but be mindful that it will take some time. If you want to know this data from Chelsea downloaded using the library rchelsea, if you want to get detailed information about this library, you can go to this website. Next, here we process temperature and precipitation data using the reverse Central Asia R package. Namely, we use the generation of HRU to these climate files. After that, we combine all the data and add discharge data to that. And we save it to the CSV file historic observation rsminerv.csv. After that, we need to cross-check our temperature data and precipitation data by plotting them in R. For example, here's our time series plot for temperature data, and here it is for precipitation data. Next, we do the historical GSM simulation from 1981 to 2010 and save these files and save it to the CSV file. After this part of the code is done, we proceed to the similar one, but for the future GSM simulations. We run it. And be careful, because this process right here in this part, future GSM simulation, may take some time. Next, we do the validation by checking model consistency, by plotting these two future simulation temperature daily mean and annual mean. Basically, what we do here in this video, using this code to download the historic observation data from Chelsea, then we get access to the historic GSM and future GSM simulations. And you may ask, Aidar, what is the difference between the Chelsea data that we are downloading right now in this code and the Chelsea data that we had access using this file browser? And the main difference, first of all, is the file format. Here we had the TIFF format that is very good for JS applications, and here in this video we use the NC format of the Chelsea dataset, and here we get the data in the NC format, and in the previous videos we used this data in TIFF format. And the resolution is different. In the NC format, we have daily data gridded with a high resolution compared to the chief climatologies of Chelsea that has annual data and monthly data. Thank you for watching this video. I hope you liked it. Write comments, put likes, and see you in the next video about bias correction.